This is lesson 4.6. It's about complex numbers. We're going to start this lesson by looking at a problem that we would have worked previously using square roots. So we have 2x squared plus 11 equals negative 37, and when we're trying to solve with square roots, our goal is to get the x squared by itself. So I want this part by itself. I'm going to start out by subtracting 11. So I have 2x squared equals negative 48. Now I'm going to divide by 2. So x squared equals negative 24. And then to get rid of a square, I'm going to square root and I'm going to square root. So now I get x is plus or minus the square root of negative 24. Okay, so we kind of have a problem here. What is this thing? Can you take the square root of negative 24? Can you take the square root of any negative number? The answer to that is no, we can't. In real numbers, when we talk about real numbers, this does not work. We can't take the square root of a negative. But this does happen enough in mathematics that we have developed a way to describe what it is that you get when you have the square root of a negative number. So we simply look at the square root of negative 1. And the square root of negative 1 we're going to label as I. It's kind of like an italicized I, just a little bit of an angle. So negative 1 equals I. And I is going to stand for imaginary. We're used to dealing with numbers that are real, that we can plot on a number line, or we can graph on a graph, or we could count up enough pennies or take enough fractions. But this new number, or this new idea, is an imaginary number because you can't really take the square root of a negative number, but we can kind of see how the concept can work itself into math. So we're going to go back to our problem now. We're going to see, what does this information do for us? How does this help me? So I'm going back to my answer of x equals the positive or negative square root of negative 24. Now this little negative part is the part that's given us difficulty. So what I'm going to do is I'm just going to change it to I, put it on the outside of my square root, and now the square root itself doesn't have a negative anymore. We can actually go ahead from here and simplify this into 4 and 6, which would make me have the positive or negative I times the square root of 4 times the square root of 6. This is the way we simplified our radicals previously. And we know that the square root of 4 is 2. So I actually have a solution of positive or negative 2i times the square root of 6. Is this a solution? Yes, it is. Is it a real solution? No, but it is an imaginary solution. So now that we've seen this I, this square root of a negative number, we're going to try some more examples of it and see what else we can do. So in a similar type problem we had before, I have x squared minus 8 is negative 36, so I'm going to add the 8 to both sides. X squared equals negative, 28. Okay, so negative 36 plus 8 is negative 28. I'm going to square root, and I'm going to square root because taking the square root of a square makes it go away. Now what do? Plus or minus, and what do we do with this negative? We make it I. Square root 28. Can 28 be simplified? Yes, it can. 4 times 7. So I can write this as x equals positive or negative I times the square root of 4 times the square root of 7. We can simplify the square root of 4 into 2. And so my solution, x equals plus or minus 2i times the square root of 7. And this plus or minus symbol still indicates that I have two solutions. One solution is positive, one solution is negative. Okay, so what else can we do with this I? We can combine like terms with I, we can distribute I, we can use FOIL with I. So here are some examples. When we want to combine our like terms, on this problem I have 9 plus I plus negative 6 plus 7I. First thing I'm doing is just removing the parentheses. Now I'm going to combine my like terms. What's like? 9 and negative 6 are both real numbers, so 9 minus 6 is 3. I and 7I are both imaginary numbers, so I plus 7I is 8I. And that's an actual solution. We can also distribute with I. Distribute. If I have 4I times negative 6 plus 4I times I, then I have negative 24I plus 4I squared. And in just a minute we're going to discuss what does this actually mean, I squared. So let's look at one more example and then we'll talk about what I squared can actually be simplified to. Alright, the last type of problem I said we could do is FOIL. First times first, outside times outside, inside times inside, last times last. So that would be negative 36 plus 63I plus 8I minus 14I squared. Now I'm going to combine some like terms. So right here I have negative 36 plus 71I minus 14I squared. Alright, so let's talk about this I squared. What is I squared? Well, we know that I is the square root of negative 1. And so, let me take this, we'll square it off for a second. Okay, so I is the square root of negative 1. So if I take this and I square it, and I take this and I square it, I squared, what happens when you take the square root and you square it? They cancel each other. The square cancels the square root and it's left with a negative 1. So what does I squared equal? It equals negative 1. So what if I do a little bit of simplification here? If I come back into my problem where I had I squared and I instead replace that with negative 1, then my problem's been changed a little bit. It looks like now I've got negative 36 plus 71I, and then this is going to end up to be plus 14. So that's definitely going to change my answer. So let's see if I've got some space for this. How about right here? So if I have negative 36 plus 71I plus 14, then now I can combine the negative 36 and the positive 14, and that's going to make negative 22 plus 71I. And that's going to be my solution. So, I is the square root of negative 1, and I squared is negative 1, which is really actually kind of cool if you're a mathematician or if you like math like I do. But the most important thing we're using I for right now is just to solve these problems. So if I have 3p squared plus 7 equals negative 9p squared plus 4, I first of all want to get the squared parts together. And remember, when we're dealing with square roots, we want to isolate the squared part as best we can. So I'm going to start off by subtracting 7 from both sides. So 12p squared equals negative 3. And I'm going to divide by 12, and I'm going to divide by 12. So p squared equals negative 1/4, because 3 over 12 reduces to negative 3 over 12 reduces to negative 1/4. Then I'm going to square root both sides, because taking the square root of a square cancels that part. So p is going to be the plus or minus square root of negative 1/4. Okay? But this is going to simplify because I can take I out of the problem. And I can actually simplify this even better because, let's see if I can find a good color, because the square root of 1/4 is the square root of 1 over the square root of 4. The square root of 1 over the square root of 4 is 1/2. So I have I times 1/2, or my final solution would actually be P equals 1/2 I with a plus or minus in front. So P equals 1/2 I. So even with fractions, we can deal with I. Okay, here's a problem for you to do on your own. You might recognize it. I did one just like it a few moments ago. And all you're going to do is simplify it and make sure you get rid of the I.